Hi everyone. What I've explained last time is a Euclidean algorithm, but I've noticed that the book actually is calculating things. One of the things that he put is actually wrong. Here in third line, where we express 80, he wrote it as 68 multiplied by 3, so that should be 68 multiplied by 1. So so it's good to note that. So one thing here is that 524 is a GCD between 524 and 148 can be calculated using the division algorithm. And the reason is that you can divide 524 by 148 and get a corresponding quotient and a remainder, and we can see that the remainder will be less than 148, so we can use that to divide 80 by 148 and keep doing this process until we arrive at the greatest common divisor. And the reason that we arrive to the greatest common divisor is because the divisor of 524 and 148 is the divisor of 148 and 80. In particular, the greatest common divisor of 524 and 148 is the greatest common divisor of 148 and 80. And so, in particular, we keep doing this process until one of the numbers is 0 and the other number is the greatest common divisor. And because the remainder keeps decreasing and decreasing, it arrives to a remainder of 0 at some point. So that's the main idea. So let's see why we can also use this to solve for the to express the greatest common divisor in terms of a linear combination of the numbers. So here we can see that we can express 4 in terms of 12 and 8. So then let's do that. I already did that here. So 4 is equal to 12 minus 8. And then you can express 12 as 80 minus 68. And here 8, you could express it as 68 minus 12. 12 times 5. So let me just calculate that in my head because sometimes you do mistakes. Yeah, so that's correct. So then you can express 12 in terms of 80 and 68. So 80 minus 68 multiplied by 5. So let's write everything down first. So that's 80 minus 68 minus 68 plus 80 multiplied by 5. Let's see, minus 68 multiplied that by 5. So here that's 80 multiplied by 6 minus 68 multiplied 1, 2, and 5, so 7. So let's check that out. So 80 times 6 minus 68 by 7. So indeed we get the 4. And now we can express 80 in terms of 524 and 148. And so what we get is 80 is 524 minus 148 by 3, and that is multiplied by 6, and 68 can be expressed in terms of 148 and 80. So 148 minus 80, which is 524 minus 148 by 3. Let's see. Yeah. Minus 80. Yeah, exactly. And then you multiply that by 7. So you get 524 minus 148 by 18 minus 148 by 7 plus 7, or 524 multiplied by 7 minus 148, multiply that by 21. So let's see. So collect all the 524 together. So you get 524 minus 148 by, let's see how many. So 18. Let's see. Okay, so you have 18 and 7, 25. Yeah, so 18 and 7 and 21. So 18 and 7. So 25 plus 21. So 46. So let's check that out if we did the algebra correctly. Let's see. Probably did the algebra wrong. So 524. So I forgot to multiply the. Yeah, so the 524 is by 6. 524 by 6. So then if we have here, then 6 and 7, so we get 13. So let's check that now. So 524 by 13 minus 148 by 46 is indeed 4. So here, that is 524 by 13 plus 148 by minus 46. So indeed we can express the 4 as a linear combination of 524 and 148. Yeah. So let's see the ideas again. So let's say we want to calculate the GCD between two numbers. Then we can use the division algorithm to subdivide one of the numbers by the other number and get a corresponding remainder as well as a quotient. Apply the division algorithm with a smaller number and the remainder, because here if we calculate the GCD of that would be equal to the GCD of the original two numbers. And because this, we can keep doing this process of the division algorithm, and because the remainder keep decreasing, it cannot decrease forever as it is bigger or equal than 0. So that means that it has to terminate at some point, and we get that this termination process by the fact that we get the same GCD to all of the terms. We get that the GCD would be the one where we have a remainder of 0. So that's the main idea. And the step before it, we can express 4 in terms of linear combination of two numbers, or in general, the GCD as a linear combination of two numbers from the Euclidean algorithm, rewriting everything from bottom to top. Then we can express the GCD in terms of a linear combination of the original two numbers that we started out with. So that's the main idea. So yeah, hope you guys enjoyed the video, and I'll see you in the next one. Thank you. Bye.